this actually very special session only made specific for Microsoft BI community. So thank you for that.
Yeah, no worries. So hello, hi. We're in full streaming mode. Look at that, love it. Yeah, so this is an interesting one. Obviously, this stuff is kind of brand spanking new. It's in preview. It's not released yet. So this is not a slick prepared session by any means. I've put together just a lot of notes to try and put it in context what this thing is, this Azure Synapse Analytics, and we'll step through. And I'll talk to what each of the different sections are, kind of where we use it or where we're expecting to use it. Because again, no one's using it in production yet because it's in preview. So a lot of this is kind of where we think it's going to be, how it compares to existing tools, kind of where we are assuming people are going to be using it in a bit. Now, I have this plan of just a few things, some quite quick demos, just to walk through and show you how it works. But by all means, if you've got any questions, if you want to know what do you think about that, hey, I currently do that in Databricks or Data Factory or SQL Data Warehouse or somewhere else, and you want to get my steer, by all means, just throw those questions out. I am happy to chuck out my plan and answer some questions if there's plenty of questions about this stuff, or I'll just keep talking at you and go through my plan. So yeah, seem like a good plan? Okay, cool. So the thing. Yeah, hi, I'm Simon. Kind of introed already, so I don't really need to introduce myself. Run a company called Advancing Analytics in the UK. We do lots of analytics and data lakes and Spark and Data Factory. I'm Director of Data Engineering, so most of my stuff is around the lakes and Spark and how you essentially currently, most like 90% of my day job is using Data Factory and using Databricks to actually basically build an automated lake. That's where I spend most of my time, is building out data platforms, using those two tools and a bunch of other stuff to stick them together. And that's the majority of my work, is helping people do that kind of thing. Now, on the other side of the business, we've got Terry, and he is the data scientist. So he's actually going off and using that platform and building off crazy advanced analytics-y things. That's kind of what we do. So we're talking about this bad boy. We're talking about Azure Synapse Analytics and trying to help you answer that question of someone saying, what is it? What is this thing that marketing will not shut up about, that Microsoft people are just constantly banging on about because this is the new thing? And is it that it's just SQL Data Warehouse, right? It's Azure SQL Data Warehouse, but with a new fancy name and some marketing, and we changed the color of it. Is that it? But it's also got this new weird thing of SQL OnDemand or SQL Serverless or SQL at your fingertips, the various different names they haven't quite settled on yet. Is that it? Or is it actually Spark, a new Spark implementation that also has Data Factory jammed into it? And it's a very confusing marketing message because it's this one tool which has just so many different components that all fit together. And essentially, it's not really a tool, it's a platform. That's the point. It's one place you can go to that has all of these things jammed together in an easy to read place. That's what they're going for. So the whole thing is to try and answer some of the marketing and answer some of the kind of the competition they've had from places like Snowflake, and they've had from other tools that go, hey, you know what? I do everything in one box. A lot of this stuff you can already do in Azure, but you have to get it from different places, and you have to integrate them and tell them how to connect. And so a lot of the message is actually just simplification. And then there's one or two new bits that are new that you can't currently do. So what is in a name? Anyone use that thing back in the day? There's the age-old thing called the Parallel Data Warehouse, which actually came from things even before then, but we're not going to go that far back. That was then rebranded into the Analytics Platform System, or Analysis Platform System, can never remember. That eventually inspired the thing in the cloud known as Azure SQL Data Warehouse. And that is an MPP engine. So that is a massively parallel processing SQL server. Basically, a SQL server with a bunch of other SQL servers on top of 60 SQL servers, all jammed together and doing parallelization of work. So you can say, here's a query, the brain thing passes the query down, splits the work up, does lots of things in parallel. It's the whole point of this thing. So it's like SQL Server, but massively in parallel. And that thing has been around since 2016, I think. It's not new. It's been around for quite some time. Now, November last year, there's a big hoo-ha, and they renamed it. It was really annoying because they made this big announcement saying, hey, we're going to come out with this brand new tool. It's called Azure Synapse Analytics. And by the way, we've also renamed an existing tool to Azure Synapse Analytics, just to confuse everybody. So there's this current thing that's currently live. If you go in the Azure portal and say, hey, I want a Synapse Analytics, it will spin up a SQL data warehouse for you. Exactly the same as the current one, no changes. That is currently called Azure Synapse Analytics in the Azure portal. And then they said, well, hey, actually, there's this new thing, which we've kind of all now settled into calling workspaces. So it's now Azure Synapse Analytics brackets workspaces is the new thing. This is the one that's currently in public preview. So it's not live yet, can't use it in production. Don't go out there and plan your entire full live system on it because it's not quite ready yet. This is the preview thing, and that's what we're talking about today, that new thing that has all the stuff in. So I'll show you a little bit of current Synapse Analytics. Used to be called SQL Data Warehouse, but that's been around for years. You don't need me to tell you what that is because there's just so much content out there to tell you about that. The new stuff is kind of the unknown, the cliff upon which we're looking over the edge and going, don't know what that's going to be. So let's dig into it. Oh, and by the way, inside Synapse Analytics, the SQL Data Warehouse bit is currently being called Provision SQL Pools. So if you see that thing, Provision SQL Pools, it used to be called Synapse Analytics, it used to be called SQL Data Warehouse, and it was inspired by APS, which was then previously called Panel Data Warehouse. That's super simple, right? Just makes sense, all this stuff and how it ties together. Whew. And you wonder why everyone is confused as to what this thing is, right? Because it's just gone through so many parallel namings and just mixed message of communication. So hopefully that clears it up a little bit. Next slide, we're going to go even further to make sure we clarify what's going on. So currently in GA, we have Data Factory right at the top. We've got SQL Data Warehouse down at the bottom. SQL Data Warehouse was renamed as Synapse Analytics in GA. That is the current state. So over there on the left-hand side, we've got Data Factory, and we've got Synapse Analytics. That's the current state. If you want to use things in production, you can go nuts. Over in the Synapse Workspaces, we've got this thing called Pipelines, which is just Data Factory, but with another name baked into Synapse Analytics. So you have Data Factory as a part of it. Now, technically, it is a slightly different version of Data Factory because it's got a few things in there to hook directly into this new Synapse preview. But you look around it and it is just Data Factory. It is Data Factory that we know and we use, and it's fairly familiar. So we've got that at the top. Down at the bottom, as I mentioned, we've got this thing called Provision SQL Pools. So that is SQL Data Warehouse, but just part of this new thing. So those two are kind of existing. Those two we know about, they are already there. And then the bits in the middle is what's new. So that Provision Spark Pools, that is Spark, it's not HD Insights, not Databricks, it is a new Spark engine hosted specifically for Synapse Analytics. So there is a new Microsoft flavor of Spark, their own little runtime they've put on top of the vanilla Spark engine, built as part of Synapse. And we'll take a look at that and we'll have a look at how it works and all that kind of stuff. But that is new. That is not a lift and shift to something else. That is a new component as part of Synapse Analytics. There's also this on-demand SQL Pools, which again has gone through several different confusing names. It is kind of like Azure SQL Database, but without a server there that can specifically query things in a lake within Synapse Analytics. And I know that is a confusing definition, right? But I have to say it's like SQL DB, not SQL Data Warehouse, because it's using the SQL DB syntax. It's not using the MPP syntax, it's using the SQL Data Warehouse, this normal SQL Engine syntax. The big difference is there's nothing provisioned. So that's kind of crazy in that you can just go write a query, hit run, and it runs. But you're not paying to have a database provision, a cluster spun up. You're not having something on Elastic Pool and managing all that stuff. It's a pay per use or pay for amount of data read. And that super useful having all that choice, right? Essentially, they've built a toolbox. You can open it up, and you've got loads of different tools that you can use in there. It also kind of muddies the waters in that you've now got four different places where you can do compute and different choices about which one to use when, what's the right one to use for which scenario. And sometimes it's like, use any, use your favorite, use which one makes sense to you. And sometimes it's like, God, don't use that one, that's going to cost you a lot of money. So it's kind of getting that balance right is going to be fairly tricky. So there's the great thing in terms of choice, flexibility is awesome. but with it comes the danger of you can use the wrong thing for the wrong thing, and you still can do that in this new one. So hopefully that kind of gives you a little bit of a flavor of the current state of the world, and I've kind of labored the point in terms of how they talk about it. So this is the thing that you see all the time from Microsoft. This is the default Synapse slide you'll see a lot of, talking about all the different things you get in there, the different languages, the different form factors. Is it provisioned? Is it on demand? But then provisioned and on demand don't apply to the two different analytics runtimes. So I think that's a terrible slide that's really confusing and doesn't tell you anything about what's going on. So beware, you'll see that, but I don't think it makes much sense. So ignore that for now. And let's talk about what's actually in there. So this is the one I put together, just to try and explain it a little bit. So compute. The actual things doing compute are the three things I mentioned. Provisioned SQL Pools, aka SQL Data Warehouse. That is provisioned, it's in the name. So I choose how big the cluster is, I turn that cluster on, and I pay for that cluster while it's turned on. Then I can log onto it, run queries, that kind of stuff. And it's because it is SQL Data Warehouse, I pay by the hour. So I turn it on for 5 minutes, use it, turn it off again, I pay for a full hour of usage. So that's like my big, chunky processing engine. It's not a switch it on, do a load of stuff, turn it off again. It's not a dynamic elastic scaling tool. It's a quite big provisioned chunky server. The SQL Engine and the SQL OnDemand, it's always turned on because you don't pay for anything unless you're using it. So it's always there at your fingertips. And they're the two different versions. So in that previous slide, when we're talking about provisioned and on-demand, that applies to SQL. We've got a provisioned version of SQL. We've got an on-demand version of SQL. Now, in the Spark side, we don't have an on-demand version of Spark. There isn't a Spark engine just sitting there that's going to instantly answer your queries. We have to provision a Spark pool, turn on a session. So that normally means it's like a 3-4 minute wait while you're waiting for your Spark session to turn on. So then you've got a little hierarchy of SQL OnDemand, instant, or second or two response times. Spark, 3 to 4 minutes. SQL Data Warehouse, 3 to 4 minutes, a little bit more, a little bit less, depending on what's going on with that cluster. So again, it's not all the same. You kind of need to know which of the compute engines is actually right for what you're doing. Then orchestration, we've got Data Factory as it was. We've also got data flows. So mapping data flows and the preview wrangling data flows are both baked in there. And that's another compute option. Because if you've used mapping data flows in Data Factory, it's kind of a drag and drop. It looks a bit like SSIS data flow. I want to pull from these streams, combine them, add some derived columns, hit go. What that actually does is take the tasks that you've done, combine it up, write it into Scala, turn it into a jar, and then sling it over to a Spark engine. It runs it in Spark. So essentially, there's a graphical Spark designer baked in that is part of Data Factory. So although I promised to talk about 3 compute options, we've actually got 4 compute options that are part of this story. It's just kind of 2 of them are Spark-based, but one of them is a graphical Spark engine. You still have to wait for the cluster to turn on. One of them is a code Spark engine. You still have to wait for the cluster to turn on. And then the SQL ones are to do with whether it's provisioned or not. Did I tell you it's confusing? It is confusing. All about these different options and different ways of working, depending on how you want to work. Storage, much more straightforward. So when you provision Synapse Analytics, you provision it on top of a Data Lake Store Gen 2. That's a blob store that has the hierarchical namespace enabled, meaning you have securable folders. That's all it is. So it automatically has a lake associated. And that, for me, is very telling about kind of the state of things, right? So 2-3 years ago, we're saying, you need a data lake. You've got an existing warehouse, you should augment it with a lake. And the fact that the first thing you need to do with Synapse is build a lake to build this up on is kind of saying, yes, almost all analytical platforms that we use these days have some kind of lake built in. And that kind of mapping data flows, the SQL OnDemand, the Spark engine, they're all based on working on a lake. It's only the provisioned SQL pool where we are then putting that data into a real provision proper database store. Everything else is either kind of querying on top of a lake and then presenting it as SQL tables, or just straight old Spark using it as data frames that don't go anywhere near that relational structures. Again, adding flexibility, but building it, at least it represents the way that we build analytical platforms these days. It is this idea of early kind of prep in a lake, moving into cleansed structured data, moving into a provisioned relational structure to present that data to people. You can kind of follow that journey with these different compute tools. The workspace itself has a lot of stuff baked in. So it is this one studio. There's a development IDE that's part of this studio. I say part of the studio, it's kind of the only place you can develop as part of the studio. It's not like there's other tools you can deploy to currently. Some of the preview stories, it doesn't currently have source control, because who needs source control, right? Monitoring's baked in, configuration's baked in. A lot of it feels a lot like Data Factory. So if you're used to using Data Factory and you've got kind of the idea of going to that new management box to get your linked services, going to the monitoring window to see your different pipelines, that's kind of the feeling that we get. So it's taking a lot from what we know, pulling it in, and then adding some more options inside it. Cool. And as we said, everything except SQL Data Warehouse is currently in preview. Just before you go and deploy this and then complain that it doesn't actually work and has no SLAs, be careful. Some of the benefits. So one of the really nice things, and this is me coming from Databricks, which has loads of really, really nice, cool stuff in the Spark side. It doesn't have a really good lake browser. It doesn't have a storage browser. So directly inside Synapse, you can just go, oh, actually just what's in the lake, and then just browse around the folder structure and then spin up stuff from that. So that is quite nice. And that's just a tiny little quality of life feature that actually I'm just going around going, oh God, that's really nice. But the big killer integration for me is this thing called Synapse Link. And that is Cosmos DB. So if you've got Cosmos DB, if you're using that kind of their document database, you can just click a button and say, oh, and just make this available in the lake for me to query in real time. So rather than having to do ETL, rather than having to hook into the change feed, suck that out, write it into your lake, and manually build all that integration, it's just a push button to say, actually, anytime someone writes a change to my Cosmos DB, I want to be able to query that immediately from Spark, SQL OnDemand, etc., all baked in. And that is kind of the Synapse story for me. So yes, I am fairly biased in terms of talking about Spark because the Databricks engine is further ahead. Kind of the Spark engine in Synapse is quite vanilla. The Databricks engine is a little bit more advanced and more mature. But then when you start talking about how easily in Synapse they can integrate into the rest of the Azure ecosystem and start actually just making up so many of these things just to turn a button and then suddenly you've got real-time reporting working inside there, that's when you start going, okay, there's some really cool stuff in here. So definitely interesting times. Right, okay, let's actually have a look at these things. Have we got any questions yet? No, all good. Okay, so Data Factory. I'm not going to talk too much about Data Factory. As it says, it's just Data Factory with some things hidden. Finding data sets, it's really annoying now. It's in a different place. Apart from that, it's pretty much exactly the same. So I'll show you that when we look at Spark and the things you need to know about the Spark engine. So one, it is a Synapse flavor of Spark. So it's not Databricks, it's not pure vanilla. It's very close to the open source vanilla version of Spark with a Microsoft runtime wrapped around it, which obviously they're going to start adding more stuff and integrating and building on. So it is a different Spark engine, but it's quite close to vanilla. It feels quite close to vanilla, especially coming from Databricks. Languages. Now this is a weird one. So Spark, the Spark engine, the entire Spark project supports Scala, Python, R, and SQL. Notice that's not one on that slide. So weirdly in Synapse Spark, they've taken out R. You've got one less language than normal in R, but they've added in C#. So you now have Spark.net. You can write C# inside a notebook inside Synapse Studio and then execute it against the Spark engine. Now that's great. And there's a whole load of people who have C# kind of applications that actually can now just query directly the Spark engine and say, I'm doing all this stuff, actually go run something massively in parallel, bring me the answers. That's cool. There's a load of C# libraries that people use that you can now just bake straight into your Spark scripts. I don't know why they've decided to alienate the entire R community by just excluding them from the Spark engine. Now, honestly, for me personally, almost everything what we do is Python. Python, occasionally some Scala if we're working with some more traditional kind of big data engineering. So we rarely do R. However, there's a lot of people out there, certainly kind of if we're building a generic platform, all the engineering tends to be Python or Scala, but then the users quite frequently use R if they came from academia, if they're like PhD, data scientists, statisticians, they're probably going to know R as their first language. And so R has a massive thing in that kind of data science community. So it's kind of odd in that we're very much looking at the engineering community when we're looking at the Spark Synapse side of things. Whether that's going to change, is it going to change by GA? Don't know. That's just the current state of things. So the kind of things that we should be using Spark for, Spark is super dynamic. So curious, can we get a show of hands actually in the chat? Who currently uses Spark? Put your hands up if you currently use Spark. I'd love to get an idea of just, is everyone going, I've no idea what this guy's talking about when he just keeps mentioning Spark? Or is it actually, most of you are going, yeah, we already use Spark. We're curious about this flavor of Spark. Okay, I've got, what, 5, 6? Okay, so out of the people, so that's not a huge percentage of the people we've got in, unless you're being lazy or you can't find that hands up button. And that's very interesting because certainly I came from Microsoft BI. That's what I did originally. I built lots of SSIS, so much SSIS, lots of MDX cubes, all that kind of stuff. And then quite a few years ago now, I switched into Spark going, oh God, this is so much easier. And it's weird because it's a more complex tool. It's a bit more codey. You have to write some programming languages, but it's so flexible. So the kind of things that we use Spark for, the kind of, the default explanation I use is data cleansing, right? If I want to say, I've got this structure, I've got either this schema of data, and I want to apply it to this data set. So I've got a load of data sitting in a folder there. I want to apply this structure. Any rows that don't match that structure, reject them and put them over there, put them in a different place. Like the classic first step of any kind of warehousing, validate your structure, chuck out bad rows. To do that, that is a single script that has parameters saying which bit data, which structure, meaning those thousands and thousands of SSIS packages where every time you want to do it to a new data set, you have to copy and paste the template, change the values, deploy it, or use BIML, but you still have to generate a new package, deploy it somewhere, check it, test it, run it. Whereas you can just write a single dynamic transformation and run it. And that is the power of Spark. So Spark, yes, hugely scalable. You can run massive, big, complex things. You can plug in a load of data science stuff. For me as an engineer, I can have a handful of scripts which do my end-to-end data processing, which is insanely powerful. So that kind of thing, if you're doing dynamic workflows, that is my key killer feature for Spark. On the downside, it can be complex. And the Spark pool session management is weird if you're coming from other Spark lands. If you're used to having a cluster, it's going to be weird. So let's go and have a look at that. Also, I have no idea how long this session takes. So give me a shout if I'm just massively going over time. Okay, right. So here we have Synapse. So like a lot of the modern tools, you have Azure. So I have Synapse provisioned here. And you have this big button saying, go and launch the studio. So like in Databricks, if I want to work with Databricks, I've got a launch Databricks workspace. If I'm working in Data Factory, I get a launch, author and monitor, and it launches a different pane. So this is all done in a separate pane that you get to from inside the Azure portal. And that'll spin up this basic landing page. This is the thing that has everything in there. And there's a load of stuff we can see on the side. So I've got data. Load of data, a lot of things that I've got, and that can be a mix of databases. And there's lots of different types of databases for your different types of on-demand compute. So is it a SQL OnDemand one? Is it a Spark database? Is it a SQL Pool database? They all have their own different databases that work in different ways. Are they linked services? So again, coming from Data Factory land, I can say, well, this is the lake that I'm sitting on. This is all the different lakes I've associated Synapse with. Here's a load of data sets that I've built. They're my Data Factory data sets saying, well, this is a data set living in, this is just a CSV in a lake. This is a SQL database. This is a Cosmos. I can go and hook up lots of different data sets in here. So I've got one pane that combines kind of the metadata of things I've done before, the actual lake I'm sitting on top of, and all the Data Factory link service type things. So it's a little bit confusing. I've got my developer area where I can just have all my different types of script. So that can be, and you can see on that list, it could be SQL scripts, and that's a mix of on-demand versus the SQL Data Warehouse ones. It can be notebooks, so these are all Spark notebooks. It can be data flows, so these are my different patterns that I've got inside Data Factory to do that GUI-driven Spark stuff. I can even have Power BI, so I can have Power BI data sets and reports all in that single space. So I've got one place to kind of keep all of my scripts with no folders and no organization and no ability to actually make it tidy. Yet, I'm assuming that's coming. I am a little bit mean, it is in preview. But essentially, you've got a one-stop place you can go for all of the different code that you've got. Orchestration, Data Factory. See why I say it's a little bit different to Data Factory, because normally I expect normal data factory, you've got pipelines, then you've got your data sets. But I no longer have that because data sets are now hidden in this data part. So again, it's the same old data factory. It's just they kind of pulled it apart and put things in different places so it all syncs in the same kind of language. But as I said, this is just straight data factory. The only difference is we've now got a Synapse bucket where we can say it's a Synapse notebook, a Spark, Java, SQL Pool. That's the only difference I've currently found from live data factory to this one. There might be one or two things that they've just rolled into data factory that they've not pulled into Synapse yet, but they're basically the same thing. And so I've got a real simple thing. People don't use data factory, the kind of things I'm doing. I've got straight copy data. So I'm just saying, you know what, I want to bring some data into my lake. So that's going off. Okay, I'm not going to talk through it too much. I'm putting out a database and saying, actually, for this table and this schema. So parameterized a call saying, I just want to give you some parameters, go get that particular table from a database. And then on the sync side, I'm saying, we'll go put it in that place in the lake. So just super generic, go get a table that I'll tell you at the time and put it in a folder and I'll tell you at the time. That's the kind of thing that we tend to build in Data Factory. Again, this is a heinous example that has no logging and orchestration in there, but it's just an example. And then that kind of thing we'd normally wrap in something like this. So I'm saying, get tables. So I'm just saying, well, actually just go and get a list of the tables that I want by doing a select star from systables. So connect to a database, work out what all the tables are, and bring that back as an array. Doing it for each loop, saying for each of those tables in that list, run that child parameter to say, I've got 10 tables, copy that table into my lake, copy that table into my lake, copy that table into my lake. That's the kind of thing that we do with Data Factory, kind of to tee up this original thing. I want to get data in my lake so I can work with it Spark, so I can work with it SQL OnDemand, all that kind of stuff. With Data Factory, I can do things like you've got the self-hosted integration runtime, which is the worst named thing in the world, the on-premise gateway. So I can say, go reach into my corporate network, grab all my data out and land it into my lake. I can integrate and pull things down into my Azure environment. And we use Data Factory to do that kind of thing. So this, I'm just going to quickly trigger that. That's going to go away, talk to my database, land them all, and then I'll have in my lake just a set of folders. And I've run this before, I can show you what that looks like. So let's get rid of that. That is as much Data Factory as you want to talk today, because that's not new. Okay, so we want to look at data. I want to show you what's in my lake. So I need to go to my data tab, that little database over here, to look at my linked data, and that's in my Azure storage. So I can go and have a look and say what's going to happen in there in my root folder. I've then got a little browser. I can go and see what's going on inside my lake. So I've organized my data into raw. So this is the first zone of my lake when I'm landing data that's I've just acquired. I've not checked it. I don't know if it's valid. I've got base, which is my middle layer where I've cleansed it. I've done some work and I've prepped it. And then I normally have enriched, curated, whatever zones of curation you're doing in your lake. That's a different talk. And for now, we've got the data coming in. So we'll see CSVs being populated. Got it organized by schema, table, and this is just by running that data factory. It's going off, grabbing that data, and just landing some data into my lake. Again, fairly rough and ready, but that gives me something I can work with, right? I've just got some data I can start playing with. Now, while we're here, there are some quite cool things I can do inside this browser. So for example, if we go back, if we grab one of those files, so grab back to my sales, I think let's go and grab one of the other ones, because that's part A. So if it sees a file type it recognizes, I've actually got some right-click context, and I can actually just do some automatic scripts. So I can say, well, just give me a notebook that queries that. Give me a SQL script that makes it an external table into SQL Pools. They're starting to build more and more of these kind of code snippets in. I don't know what kind of criminal actually works on a file basis in the lake, but apparently that's the assumption that's been made. Most lake things, you'd work on a folder, and you'd say, I want to create a data frame over that folder. But it's currently at the file level, which is fine. But there's lots of stuff in there. So let's talk Spark. So down here in my manage area, that's when I can work with my different types of compute. So if I want to talk Spark, I need to have a Spark pool. I need to have some kind of compute in Spark. If I want to talk SQL, I need to have SQL pool. If I want to talk SQL provisioned, I need to have a cluster. So when you're working with the different types of compute, everything's down in this managed tab. So I've got two things. I've got Spark SQL Pools and I've got Spark Pools. Now in SQL Pools, by default, you will always have a SQL OnDemand. That's the one that's just turned on that doesn't cost you any money. That's just always running. Well, it doesn't cost you any money when it's not doing anything. The moment you query it, it costs you money. Don't get me wrong, it's not free. But that's just provision. That's just there on, it's not costing you money while it's turned on, it's costing you money when you use it. I've got a SQL pool, and we'll come back to that later. That's essentially just SQL data warehouse, but living in this new home. The thing we'll talk about now is Spark Pools. So Spark Pools is a weird concept. So if you're coming from the Spark side of things, Spark, you provision a cluster. So you have a driver node, you have kind of the brain that's kind of your orchestrator that receives your commands, works out how to execute it. And then you have workers. So you have a variable number of workers, which are the things that they soak up the data, they do the compute. Each one is doing a different bit of compute on a different bit of data, and you're parallelizing work across these workers. So it's all about making sure you spread the work effectively across those workers, deciding how many workers you want and how big those workers should be normally. So certainly Databricks land, HD Insight, EMI doing over in Amazon, that kind of thing is all about what should my cluster look like, and then you fire jobs at that cluster, and the cluster works out what space it has, what it's got free. That's not how this works. So here we decide on a pool. So that is, what are all the different potential clusters we could be running at once? Clusters are a bad word, it's Spark sessions. So I can say, I want a Spark session that's using 3 workers. I want a Spark session that's using 4 workers. I can decide how many of those chunky servers I want to be using for an individual session. And my pool is the total amount I want available. So if I wanted it potentially possible for 2 people to be using a session that had 4 workers each, I'd provision a Spark pool that had 8 workers. So that doesn't mean when someone's using it, they're going to get 8 workers. When someone's using it, they pick a slice. I'm going to use this much of my existing pool. And that was super confusing to me when I first started. So I've got a pool that's already there. You can see it's made up of small nodes. So that's the size of each worker is a small, which is just 4 CPUs, 32 gig. And I'm saying I'm allowing 33 to 40 nodes, and it's auto scaling. So if someone just connects, they're going to use a driver on 2 of those nodes. Someone else connects, it'll scale up that pool and use more. So it's kind of just working out what is the available capacity that I want at any one time. Now, my problem with that is that that sends an error if it's full. So if I want to parallelize and just go, hey, look, here's 100 things, go do them in parallel, it will eat up sessions until it gets full, and then it'll just start erroring, going, nope, 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 nope. Whereas in other things like Databricks, that would get into a queue, and they just sit in the queue, wait until the cluster's free, and then just run on the available slots. So it's a very different approach. It's very much expecting you to have a siloed, this is one job is the only thing running in this particular cluster. Now the approach of that is to stop data bleed, is to mean it's, it's 100% running in its own environment. There's no sharing of tenancy or any of that kind of stuff. But it does mean it's fairly inflexible for doing lots of things in parallel. So it tends to be an engineering job. I've got one big thing to do, start it, finish it. It's not kind of a high concurrency. I've got a bank of 100 users who want to be grilling SQL with different ways. So different way of thinking. I choose my Spark thing. I choose how big it is. I choose how many nodes. So I can say I just want it a fixed number of nodes. That's as big as it ever is. I can allow it to scale between certain amounts. And it's, yeah, kind of makes sense when you start thinking about it that way, but it is a little bit weird. Where I'm spending a lot of time on Spark here. We can do auto pulls. We can tell it to turn off after a certain amount of time. This is an important one for me, the Spark version. So the current version of Spark that is live, that people have adopted as of 3-4 months ago, is Spark 3.0. And that has a ton of features to do with making things like star schemas actually something you can query effectively. Loads of performance improvements, loads of really, really cool stuff in Spark 3. We don't have that in Synapse yet. So we're expecting to see it at some point. It's a little bit unfair of them because they are building this thing in preview and the goalposts are just moving and moving and moving with the kind of the outside project. So you can kind of see it is a difficult balance. But yeah, be aware if you're currently using Spark, you're thinking about moving over to Synapse, it is currently locked in 2.4. And then it has a lot of stuff built in. So it's automatically got .NET on there. It's automatically got .NET for Spark. It's automatically got Delta Lake. Now, Delta is a really cool file format that's like a transactional wrapper on top of Parquet. So if you're doing any kind of analytical queries in a lake, Parquet makes it behave. It gives it ACID transactions. It gives it merge functionality. It gives you time for time travel. Delta's really cool. Doesn't work with everything in Synapse. Okay, so we do something like that. We set up a Spark pool, and then we go out and back into an actual notebook. Inside a notebook, we can say, in this one, I want to be working with a particular session. So I've got a load of script. I can choose my language, PySpark, Spark, .NET. Is it SQL? And again, that's the confusing thing. Spark has its own flavor of SQL. So even though I've got SQL OnDemand and I've got SQL Provision, SQL Pools, the Spark thing is another place I can write a slightly different flavor of SQL if I want that to run in the Spark ecosystem, which again, very confusing if you're just coming into this fresh. But by default, you pick a language for the notebook. So this notebook, because I've selected that, it assumes everything is PySpark. SQL is a little, Spark's a little bit weird because I can actually just go, just treat this bit as SQL. And then cell by cell, I can switch languages between Scala, .NET, PySpark. It's super flexible how you can build these things. Not necessarily a good idea to do every notebook is a mix of every single language. That's incredibly hard to support, but you can. And then right down at the bottom, hidden, I've got this little configure session button. So that's saying how much of that Spark pool am I currently using? So for this session on this notebook, I want to attach it to a Spark pool. It tells me how utilized my Spark pool is, tells me how many sessions I can go on there, and I can go and choose, well, actually, I want to take a lot of that Spark pool. I just want to use a little bit of it. I'm choosing how much of my available resource, so I said, people can use up to 40, how much do I want to take in this one session, and I can say go. And that'll start turning on my Spark server. So it's very different. It's not like the other thing, not like SQL Data Warehouse, where I turn the whole thing on and then people can use it. It's user by user, or actually notebook by notebook. I connect it and I decide how much of that I want to be using. And while I'm using it, I'm locking everyone else out of that bit. So if I've said my Spark pool has 2 nodes on it and I'm using 2 nodes in the session, no one else can write a notebook against my Spark pool. So interesting in terms of resource contention and all that kind of stuff. That's going to take a little moment to turn on. So we're going to switch. I'll keep talking about the other stuff, and then we'll show you that Spark code, and we'll kind of look at the SQL OnDemand when we do it. How are we doing for time? No idea what time it is. We good? Okay. Right, so SQL OnDemand. Again, build per terabyte read. So if you run a query and it reads a load of data, it works out how much data went through the service, and it bills you that amount. And currently, it's kind of blind. It doesn't tell you how much it's read. So you just run a query and you find out the next day how much your Azure subscription is being charged. And obviously, they are well aware that that is not something that's cool. That is very much the previous state of things. But it'll be interesting to see how that ends up when it goes live. Are we going to see a little thing at the top going, you're about to spend this much money? Or do you run it and then go, oh, that was 2 terabytes. Oh, I meant to filter it. It'll be interesting to see how we manage budgeting and constraints, given that's basically a run it, see how much you spent afterwards. However, really cool that you can just write a query and hit go, and it works. Like, first time I was trying it was like milliseconds, just goes in, reads some Parquet and like brings me the data back straight away, which is awesome. It's T-SQL. As I said, it is the SQLDB flavor of T-SQL. I don't think it's full compatibility. It's very weird in that it doesn't have a database, if that makes sense. You don't store data in it. So you see a logical database structure. You see database with tables and views and things, but you can't create a table and insert data into it because it's not a real thing. It's an ephemeral server that's used to query stuff. So you can only use it to create kind of metadata constructs. You can create like views and external tables, pointers to data held in the lake and other places, but you can't store data in it because it's not a real database. It's just a querying engine. So a little bit weird getting used to it. And there's going to be some patterns that we're going to try and have to work out. Because you imagine this is you pay per use. So if you have one thing, kind of you want to run a query, you want to refresh a Power BI model, this is just a SQL endpoint. So you can say, well, this is the endpoint to my Power BI model. It's going to refresh every night. It do that query, pull it back. You just get charged for what it read. That's going to be fairly cheap. I see this being one of the primary ways of accessing data, going through the SQL OnDemand endpoint, super, super cheap. However, because it's a SQL endpoint, it's also accessible through things like direct query. So I could make this the endpoint behind a Power BI model that is just every time a user goes in, it's querying it. And then if I've got thousands of users, suddenly I'm hammering this thing. I'm paying way more than I would if I just stood up a provisioned SQL Data Warehouse. So there's going to be patterns of going, how much are you going to use it? And then eventually it'll tweak over and go, oh, it's probably a more expensive way to do it. So it'll be interesting, and it's going to be hard to know in advance. So I kind of assume a lot of the time we'll start off using this. This is the prototyping. This is the just fuck it up. You don't need to do any planning. Just start working on it. And then if people start hammering and you go, okay, this is going a lot. Let's actually move this into my provision SQL Data Warehouse. and then you can start to manage it, but we just don't know yet. So it's an interesting idea and it's an interesting approach, but it's kind of the unknown. Again, unpredictable billing, it's a very black box. You can't really see what it did. You can't really see the query engine. You can't say what was the query plan for the thing I've just done. It's hard to say, did this hit partitioning? So if I've got like a terabyte of data, but in a data lake, you do partitioning by managing it up into folders. So actually, if actually the thing I wanted it to read only needed to read one folder of that and it needed to read 200 gig, not the whole terabyte. Did my query hit it? Am I going to find out whether my query hit it now or tomorrow? It's really hard to actually work out what that looks like. There is a in-flight monitor. So you can go in there while the query is running and see what's happening. But if it finishes too quick and you don't get to it, you can't get to it. Now that may have changed. That is definitely something they're planning on fixing or changing. That's kind of definitely one of the conversations we had. I don't know if that's, I think that, I don't know, we'll see. Okay, let's go have a look at what that looks like. So, oh, did I not actually start I didn't start my Spark session. Oh, I configured it, but I didn't hit go, so it didn't start. Now it's starting my Spark session. So we'll let that go. I'll talk through this code. Okay, so this is still in Spark. This isn't in SQL OnDemand yet. So I've got some parameters. I'm saying this is my folder name, this is my schema name, this is my table name. Remember, that's how I've teed up those folders that are sitting in my lake. And I'm saying I want to have a string. I want to make a string variable. So my string is made up of this kind of folder structure, and I'm injecting two variables into it. I'm saying we'll just have a dynamic string, replace the SCH with my actual schema name, the TBL with my table name, and that's just a nice dynamic string. It's called an F string in Python. All good. I'm doing the same on the save location. So I'm parameterizing, this is where to get the data from, this is where to put the data, straightforward, and I'm making a nice little message. So that's what it'll look like. So using those parameters, it turns my, this is where I'm going to get data from, this is where I'm putting data. And then I'm doing a little bit of Spark. So I'm saying I want a data frame. Data frame is a data variable object. And I'm saying use the Spark reader. So I've got a Spark session, go and read some data, expect it to be a CSV. I want you to look at the CSV and work out data types. So do a bit of sampling and say, well, that's an int, that's a string, that's going to be a date time. I want you to ignore the top header row and use it to work out what the column names are. So this is, again, super dynamic. I don't need to say in advance, here's all the columns to expect, here's the data types to expect. I'm saying, Spark, figure it out. Meaning I can run this same bit of code for 5, 10, 100 different data sets, and it will work out the individual structure and the types without me having to specify it. And I'm saying go off and load it. And I'm passing in that location in the lake. So again, nice, super dynamic. With this schema, with this table name, I can just run this for any of those tables I've loaded. Again, when it turns on, I can show you that. Okay, and then writing out. So I'm saying, well, the same again. I want to write it out. In this case, Parquet. So it's going to be ColumnStore. I want you to store this as column optimized files. Parquet is kind of good because it's got the structure in-based. So CSV, I have to tell it this is the data format. Parquet, it knows it's already got these. I've got 10 columns. This one's a string, this one's an int, all that kind of stuff. Again, I would use Delta. Delta doesn't work with SQL OnDemand. And I'll show you the particular thing I'm trying to get working with SQL OnDemand. And it's neat, but it doesn't work yet. Okay, so we'll do that. We'll write it down. And then we'll just count it. So how's my session? My session's still starting. I'm going to hit run and wait for that to happen. We'll go and have a look. The thing we're trying to do is this bit at the end. So once I've written it to the lake, so we've got some CSVs in my raw folder. Spark's going to pick it up, look at the data, work it out, and then it's going to put it down in Parquet format again to the lake. And then here I can say, I want to create a Spark database. So I'm just running a little bit of SQL. I could do that via that percentage SQL instead. Here I'm just saying Spark to SQL, run this little bit of SQL, saying create a database called MsBIP. So I'm going to make a new Spark database. And then inside that database, I'm going to add my new table by pointing at a location. So that Parquet file I've landed in the lake, I'm going to just register that Parquet file inside my Spark database. So I'm going to end up with just metadata, just a list of things that look like SQL tables. It's actually Parquet. The data's still held in Parquet in my lake, but I can see it as a SQL table. Very importantly, there we go. So my Spark session is ready. I'm going to hit run all. That's going to go through, run all these things, and then start copying these things over. So over here, in my list of workspace data sets, I can see I don't currently have that MsBIP. So I'm expecting at the end of the script there to be a new database and the product table to exist in it. So I'll have a queryable table called product in my Spark environment at the end of this. You go through, it's thinking about things. It's in progress, so it's currently doing the read, working out. That'll go through, and we can have a look. And then when we've got that, that's accessible to my other compute engines, which is kind of cool. So thinking about things. There we go. So we've got a data frame. You can see the structure that it found. So it worked out product ID, it's got the name, it's got a product number. It's written the data out of the lake, so that's succeeded, so that's now there. Run those other things. It's now running the correct database. So in a moment, we should see those things created, which is good. Everything is going to plan. It'd be better if I'd started that Spark session on time, but you know, say la vie. Okay, there we go. So there we go. We've got a new Spark database. Notice that is a Spark database, and that's slightly different. So that is a thing called Hive, and that is a very big open data way of storing data, storing metadata around data lakes from the Hadoop ecosystem. So Hive is an existing thing in Apache. And then we'll see tables under that. So is it creating the table? Still thinking about it? Done. Okay, so I think I need to refresh. Oh, there we go. So we've got product. It's registered that table, and we have a list of columns. That is now a known metadata registered table. People can go in there and query that table. And I can query it in Spark. So I can just go and query it within there. Oops. So I can query. I can go and load it into a data frame and then work in Spark. Most importantly, I can see that from SQL OnDemand, which is kind of cool. So let's do that. We can go, I want to do a new SQL script. And then up here, which of my various different SQL endpoints am I using? Am I using my on-demand one? Am I using a provisioned SQL data warehouse, which again, I'm paying for by the hour while it's turned on? I can choose which of my various SQL pools. So if I'm in SQL OnDemand, I can then, like any other SQL, pick my database. You can see, I can now see that MsBIP is available as a database for me to query. So despite the fact that it's a Spark endpoint, that's actually replicated over. So there's a copy of it made accessible to my SQL OnDemand. So I can just go in here and go, I want to select star from, what do they call it? Just product. No, didn't know what it was called. Okay, it's not called that. What did I call my table? No, so I think this is the weird one of it being case sensitive. Fine, let's do it the easy way. Ah, there we go, MsBIP. Okay, there we go. So that is accessible to the other side. So this is my T-SQL engine running on demand, querying something I've landed in the lake that's Spark. That is a Parquet file. So that is actually sitting, that's the one that went in here. We copied that over into our base layer. So it's essentially doing a query on top of AdventureWorks, on top of Sales LT, on this customer table, on the customer table, on the product table, whatever I called it. I didn't rename it. Going through and querying it in real time. Now that's all right, that's quite nice. And it's an okay SQL engine. The thing that makes it really cool, and the thing that really annoys me every time I'm speaking to a client and I'm like going, hey, look, you can do SQL in Spark. And they're like, can you use SQL Management Studio? No, you can do a notebook. You can use the whole shiny notebook experience. And they go, I want to use SQL Management Studio. Well, the good news is you can. So the SQL OnDemand endpoint, you have two endpoints. The one going and you can go and talk to your data warehouse and your other SQL pools, and one specifically for the on-demand endpoint. So if we get SSMS up, we can connect to that. We'll see the same databases, and we can query the lake live directly from SSMS, which again is really cool. And that's just building out. So using the automation of Spark and Hive and saying just loop over these 100 things and just do this programmatically, I can then build up a database I can go and access. So again, this is connecting to that endpoint already. I'm connecting using Active Directory. So it's connecting as me. I can go in. You can see my list of databases. Normally, I don't think I can zoom effectively when I'm in Manifest Studio. But believe me, MSIP is there, or MBSIP. We can go in, see our tables, and we won't see anything. Oh, that's interesting. I can't see my table. Boom. So that same script we can copy over. And I should be able to run this. Will this tell me no? There we go. So again, live querying of lakes via an on-demand SQL process I'm not having to provision in advance, that doesn't have a startup time, done from Management Studio. Pretty cool. All right, on with the show, not into reading mode. Okay, the other bit I don't want to spend too long in. So provision SQL Pools, that's classic SQL data warehouse, but now in its new land, build per hour. Again, T-SQL, but the MPP parallel data warehouse flavor of T-SQL. And it's for that kind of, I've got a big data set. And that's the only place where we can land data and store it within a SQL table here. If it's in SQL OnDemand, it's just a metadata pointer to something in the lake. If it's in Spark, everything is held in the lake. All the different compute options are lake compute options, except for this, where we can have external tables. We can do the same thing that we can currently do and kind of make these external pointing things, but we also have distributions. We have the ability to say, well, create table as select, pull from an external table, land it properly inside my warehouse, and we can hook those things up. Scaling, it's not that flexible. So in terms of scaling, can I have to provision the whole thing? Currently, if I want to change the size of your the particular cluster, I need to actually turn it off and make it bigger, make it smaller. If someone's running a query and I decide to change the size of my SQL pool, their query gets killed, which is awful. And there's a question, well, there's a point in the comment going, yes, that is a very good point that my table in Management Studio was an external table and is therefore not visible in tables. That's a very good point. Sure, fine. Makes sense why it's not there. Because again, you don't have actual tables in SQL OnDemand. And yeah, the other point in SQL Data Warehouse, it can be expensive. Because it needs to be a certain size before it can actually work properly. So sizing in SQL Data Warehouse is a bit of a weird thing. So let's go and have a look. So when we're provisioning this, we provision our SQL pool. Again, so we go to SQL Pools when we're looking and talking about this because it's provisioned one. And I've got one currently, but I can say I want a new provisioned SQL pool. And I get the same kind of questions I get if I create a new SQL Data Warehouse currently. What do I want it called? MsBIP. And then I get the performance level. How many data warehouse units do I want? DWOs, how many of those things? Now in Gen 1 of data warehouse, we had 100 to 6,000. And each 100 data warehouse units was a new compute node. So like we're talking about in SQL Server, in Spark, we've got that driver and we've got a number of workers. Data warehouse is working the same way. We have a driver and then we have compute nodes. And each compute node is a chunky old SQL Server that's meant for doing things in parallel. Now, with Gen 2, when they changed over this C, actually every 500 is a compute node. The compute nodes are much bigger, much chunkier, and so it kind of scales in 500s when you get to the larger sizes. So each one of those is a full compute node that you can use. Now the lower ones, 1 to 500, that's kind of like carving up part of a compute node. So that's there for dev. It's for dev and test, playing around with the things, having a play, but kind of the minimum production level is 500, and that's one compute node. So the minimum level to entry is fairly expensive. So what, £4.50 an hour? And you have to use a full hour. You think about having that permanently turned on all day, every day as the main serving layer for your users, that's already quite a lot of money. And then when you talk about actually, we've got a huge amount of data, we've got several terabytes of data, we want to have that just available all the time, you're talking lots of money. So it's basically the barrier to entry of using provisioned SQL Pools is you need to have quite a lot of data and you need to have a lot of people using it. You need to be using it a lot to make it worth it. It's not a use it once per hour because you're paying a lot of money to do that. For those kind of use cases, maybe use SQL OnDemand instead, because then you're not paying for that continuous uptime. So you need that, and it has to be turned on before you can use it. So you can pause it. You need to automate the pausing of it. So I can go in here, I can click that pause button, and it'll turn it off. I'm not going to do that just before a demo. But I can go in, I can choose how big it is. I think I'm being super cheap. I can go and see what's going on in there. You've got collation, you've got size. I'm being very cheap. I'm on the smallest amount possible because I don't want to waste all of my money. Okay, so we've got that turned on. And then when we're there, again, we can use it now through this same browser. So when we're working with things, we can actually say, well, actually, I want to run this same query, but using SQL OnDemand. Some of the things like this, it won't work. So it won't be able to see that replicated table yet. But then other things we can do. So we can go in our root table I'm going to find some Parquet somewhere. I just grab a file out of here. So I can grab that Parquet. I can right click. I've got this context menu, and I can say I want to create an external table. So I want to actually make this accessible within my SQL Data Warehouse. Which pool do I want to make it in? I want to use it in my data warehouse, in my provision SQL pool. Which database? I've only got one in there. What do I want to call it? I want to call this DBO.customer. And then do I want it to just happen automatically or make me a script? In this case, I'd like it to make me a script. Goes away, gives me a new thing, and it's doing all the hard bits for me. So when using SQL Data Warehouse, normally you have to go and create certain objects to be able to use Polybase. So if I'm using Polybase, I need an external file format. I need a data source. I need a credential store. And this just has scripted out those. Again, because Synapse is already integrated with this lake, it can just grab all the credentials, all the authentication automatically. And then it's creating that table. So it's gone, it's looked at what's currently in there, it's read the Parquet to work out those data types. It'll go off and create it, filled out all the things I need. So I can actually just run this script. Again, running inside my SQL Data Warehouse, and that's going to go and create that as an external table. There we go. So that now has a permanent object that's in my external tables that's hooked up to that particular customer file. So looking at that one Parquet file. Again, I'd like to be able to do it by right-clicking on a directory, not on a single file, because who just has one single file? But still. And then we can do things like we can do a CTAS. So the create table as select script. It's the classic mainstay of those people like me in SQL Data Warehouse land. So I want to create a new table. This is what I call it. So this is going to create an actual physical table. I need to give it some stats. So I need to say what kind of index. Should I have a clustered ColumnStore? Should I have a heap? So how do I want to organize it? And then I have this thing, distribution. So I need to tell it how to organize that data across the actual data store. So underneath SQL Data Warehouse, it has 60 distributions. There are 60, basically 60 little SQL databases. And when I say just put some data in there, it puts data in all of those different databases. So when I say select star from this table, it runs a little query across 60 different things to pull it all back. That's how it's getting parallelism together. So this distribution choice is saying, how does it decide how to spread that data out? Round robin is as smooth as possible. Just make it all evenly distributed. I don't want to have one of those 60 with loads of data, so that one takes ages when everything else finishes really quickly, because you're only as fast as your slowest distribution. So skew is the devil here. We do not like skew. So round robin is make it smooth. Smooth it out. I can also do hash. So I can say I want to hash on the customer ID. And that'd be a terrible idea. I'd never do that on the customer ID. But that's basically saying co-locate all similar records. All records with the same value should live on the same distribution. Now, if you imagine that in this table, quite often people will go select from customer where customer ID equals and give it a value. And then that query is not going to run in parallel because all that data should be on a single database. So hashing on a search predicate or a join key, generally not great. But I might have something that if I maybe join on that key, but I always join on all values of that key, that might work. If I have something just I know has good cardinality and it's good, actually, there's a good spread of data, that might work. Like some kind of dates occasionally. Dates can be very tricky because I'm doing it on sales date, and then Black Friday has 20 times more values than everything else. Suddenly I've got skew. So hash is really good for optimizing, but comes with warning. You have to know your data to decide what hash key. Final version, I can say replicate. And that's saying, well, actually, I don't really care how it's spread on the across the different distributions. I want a little copy of this table on each of my compute nodes. So I've said data warehouse 1000. That means I've got 2 different compute nodes. I'm saying just take a full cut of that table and keep it on both. So I never have to worry about going back to the distributions and worrying about data. I can just join to it immediately. So if I've got things like I'm doing a star schema, then I might choose to distribute my fact based around a hash key that I manage. And then my dimensions that are all fairly small, I can just replicate them all. And then I don't worry about join dynamics between my distributions. So there's lots of modeling that comes to play. Hopefully that's the thing that is striking. Going, when I'm landing data in the data warehouse, the key thing is how you structure it, how you join them together, how you decide how you spread that data out. And that is a whole technical argument of its own. I've done deep dive sessions about how to distribute data in a warehouse for effective querying. It's not that straightforward. But then there's a lot of grunt behind it. So a lot of the time you're kind of okay going just round robin it and then join it to some replicated tables. Kind of works all right these days. But there's a lot to it. Hopefully that's fairly clear. Cool. Okay, so that is an absolute high-level view of what SQL Pools look like. So we've got those external tables to get data in. CTAS is one of the things that we're using a lot to say create table of select, moving things around. And we do have this bonus compute, that mapping data flow, which don't have time, not going to go into. I can show you a picture of it. That's build. You get like a little data factory bill in terms of, you get a little poke, number of executions, and it has session uptime. So that's working on a Spark pool. It's working on a Spark session that turns on and then you're charged while that's turned on. That's similar. Now, I don't think it can currently share the Spark pool. So currently it runs on its own Spark session that's not the Spark pools that you've defined. And that's all a little bit up in the air. It's GUI. So again, it's a nice graphic user interface. If that view of that PySpark was like, oh, code, then this is the thing for you. Really straightforward, really draggy droppy. And it's a nice tool for people who are coming from the SSIS point of view. It looks familiar. It's not as dynamic as pure Spark. So that kind of like, I want to write a script that can just do anything on anything I throw it and just run that generic script. It's quite hard to get mapping data flows to reach that level of parameterization. So you can do some generic things. It's getting better at being parameter driven, but it's nowhere near the full mad, I can write one script to rule them all side of Spark. And again, doesn't seem to use the existing Spark pools currently. Cool, so kind of touching them together, I put a little overview slide. Again, I'll share these slides. I just put all that into one, so you've got a quick handy guide of what happens with there. And again, that little reminder of those different types of compute. So we've got the data warehouse, that's the DWOs, that's provisioned, that is turned on, big chunky server. You've got your Spark pools, where you say, this is the potential amount I want to be using. Then each notebook kind of uses a little slot of that. And then SQL OnDemand doesn't have any of that. SQL OnDemand is just, as you use it, it's going to charge you something, and we'll see. So kind of have those in the back of your mind. And yeah, I know at the end of that, you might be sitting there going, well, that hasn't clarified anything. If anything, I've got more questions. There's more different options. There's so many different ways you can use this beast. And that is kind of, there is a lot to it. There's a lot behind what's going on there. Hopefully, kind of showing you there's a lot you can do with it. There's a lot of potential. And it's going to be interesting as it kind of comes up when we eventually see it going into production, when it becomes GA, kind of how much will it kind of, they've smoothed some of those things out. How much will it kind of that messaging be a lot clearer going, this is what you should use this for. This is what you should use this for. And currently it is kind of this whole beast. Again, a little plug, we are doing a training session, which is looking like it's going to be on the preview version. So there are some going to be things that are going to change, going to work around. And essentially that's going through in detail each of those steps. So it's having a look at Data Factory, giving you that kind of sheep dip into how Data Factory works, how SQL Data Warehouse works in this new world, how Spark works in this new world. Because actually we've done deep training in Databricks and Spark, in ADF, in SQL Data Warehouse. And a lot of those learnings you can kind of bring into it. Kind of, I would normally be wary of someone going, hey, I've got a training session on a new preview product. You'd go, have you? But actually, it's a lot of existing lessons, there's a lot of existing techniques and patterns that we can take and apply to this, and then working with the new stuff. And it's going to be interesting to question going through it, going, so how does on-demand pools work? How does the Spark engine actually compare to other approaches and other ways of working? So yeah, going to be an interesting session, and that is coming soon. And that is all that I had in my little pack of ramblings. Yeah, any questions?
Thank you very much, Simon. I don't think we have any questions, actually. Oh, yeah. Yeah.
Does Synapse Analytics share data connectors with ADF? Well, so it doesn't share them in terms of if you create them, they're visible in the other one. Currently, it does share the ones that are available in one are available in the other, or at least unless they've just been added. The ones that are a little bit confusing are things like the inline ones that are just being added. So the ability to write to Delta, the ability to write to Excel. I'm not sure if they're in both yet, but generally parity is fairly close. We didn't talk too much about Delta. There is one question I got asked last time I did this demo, just to really quickly poke at it. So that SQL script, so the Spark script, sorry, when I was saying, let's take this data and let's land it into that table. So we're registering that and we're landing it in that Spark table. The reason that this is going as Parquet, not as Delta, because the ability to query these Spark tables. So if I'm in SQL OnDemand and I query my Spark table, which is up here. So blah, blah, blah. So the reason SQL OnDemand can see that database, even though it's labeled as Spark, it actually replicates definitions over into a SQL OnDemand friendly version. And it only does that for Parquet. So if I save a Delta table, despite the fact Delta is a de facto file format for lakes now, it's a very advanced file format for lakes now, SQL OnDemand can't read it natively from the Hive store. Again, that's one of the things I really hope they fix before GA, because pretty much everything we do in Spark these days is now Delta. So being able to query Delta files directly from SQL OnDemand and from Power BI and all that kind of stuff is a huge, huge, huge win, but that's not currently there.
Yeah, okay. We have one more question here.
Yeah. So will data scientists be able to use Synapse, or is it just for data engineers? I don't know. So there is integration into Azure ML. So if you're using the Azure Machine Learning Services, there is quite neat integration in the notebook side over into Azure ML, and I think back. So there's definitely plans for that side of things to work nicely. In terms of how nicely will this hook up to other things, so if you're using things like PyCharm or Anaconda, if you've got kind of using an IDE locally, which a lot of data scientists we know like to use, how cleanly can you get that to talk to Synapse? Don't know yet. How well can you talk to it against other areas of it? Not that sure. Certainly, there's a big push. A lot of the documentation is saying use Spark ML, use ML.NET. Kind of certainly use the C# thing they're pushing quite heavily. Integrating into cognitive services is something they're pushing quite a lot. So certainly the answer is, if you're using the Azure baked-in data science tools, hell yes, it is all deliberately quite geared to do that. Will it actually capture a lot of what people working out in open source land, out in the wild doing data science, will it actually fit their needs? Yet to be seen. What do I miss the most in Synapse Analytics right now? A few things. Mainly for me, again, because I do most of my work in Spark, the Spark pools are a little bit inflexible. I'm used to being able to spin up a cluster and then have lots of people share that cluster and slot in and kind of go in a workload queue. That doesn't work that well in Spark pools currently. It has that idea that it's a one job, spins up one session, then it finishes. So you end up either waiting for people to finish with their session or having to massively over provision a massive Spark pool. So kind of the flexibility to be able to go, like, let's just make Spark really elastically scale. And Spark 3.0, because Spark 3.0 has things like adaptive query execution, has dynamic partition pruning, has a ton of features that speed up querying across a big fact table, lots of dimensions. You don't traditionally do Kimball star schema things in lakes because it's slow at doing that, whereas Spark 3 has enabled that kind of pattern. There's lots of things you can now do because of the latest engine and the updated query optimizer. That not being in there is a little bit limiting.
Yeah, we have a Kahoot quiz here at the end. So we have 15 minutes left. I think that will be good. Maybe one last question here, and then we'll have the Kahoot quiz.
No, we'll sneak you on. Let's have a look. Okay, so question is, Power BI integration, will it have to go through Power BI desktop before a dataset can be published? Or can you connect directly from Power BI to Synapse? Bit of both. So currently, to create a dataset, you cannot create a new dataset from Synapse currently. But it is a SQL OnDemand endpoint. So you can, if you want to create a dataset in the Power BI service or in Power BI desktop, you can point them both to that SQL endpoint and create a dataset from there. Weirdly, you can create reports. So if we're in that kind of develop thing, again, I'm not going to spend a lot of time on that. I'm not a Power BI person, you can talk to us for that. So in here, we do have the ability. So the data set is something I had to create in Power BI desktop and deploy. Reports, I can go and actually sort of have a play with, I can go and edit. And you get kind of the report designers baked in. So it's a bit of a weird mix in that kind of, weirdly, the middle step, that middle set of data sets is not currently available, but you can deploy them to it. But then data sets from elsewhere, you can just point to this directly and say, "Would you go query that SQL endpoint as if it was any other SQL database?" So it's kind of like a bit of both.